Good everyone, my name is Graphics. Now if you look at the front of the screen, you see an information, a question there that says that a machine component 1.5 meter long and weigh 1000 Newton is supported by 2 ropes, right? Now this is the machine component here and this is the rope that is supporting it, right? A, B and C, D. So let's say this is A and this is point B, this is C and this is what? D, right? A, B and C, D shown, right? Calculate the forces T1 and T2 in the rope. Now due to the weight of this, which we are told that the weight is acting downward, right? Weight will always act downward and is what? 1000 Newton, right? There will be a force as a result of what? The tension on the rope, trying to keep it stable, right? So we see there will be a tension at this point. You can put it this way, T1, and this way also. You can see this is what? T2, right? I can put it this way also. There will be a tension at those 2 points there, right? Now we are told the length of the machine component is 1.5. That means from here to 1.5. Now since we are looking for the force, the length is not important. Now we have to draw the free body diagram of this machine component. And let's see, there are different ways you can do this, but one of the ways I need to do this is this. First of all, let us draw the free body diagram. In drawing the free body diagram, we know we have 2 forces meeting at this machine component, and the machine component is acting downward. So the free body diagram of this will be this. So let's see how that goes. So I'm going to draw the weight of that machine component going downward, right? This is the weight of the machine component going downward, and I'll call it W, and that is 1000 Newton, right? Now the other one, which is this acting to the machine component, is at an angle of 60 degrees. So it's going this direction. This is at an angle of what? 60 degrees. Does the same thing. So acting this way, the angle there is what? 60 degrees to the horizontal, right? So I'll just show this. So the angle here is what? Angle 60 degrees, right? And that is, I'll call it TAB, right? Which is also known as what? Our T1. I'll call it T1, right? Now the other one is at an angle of what? 45 degrees. This is what we have here, at an angle of 45 degrees. So I'll put that, and I'll be having something like this. This is 45, right? So force here have TCD, isn't it? I'm saying T2, and the angle here is an angle of what? 45 degrees, right? Now this is a concurrent coplanar force. They are all meeting at a point here, right? So if I should just complete this at the center, watch, I'll have this way, because we don't really know the angle between here and here. So in knowing the angle between here and here, it's as simple as this. We know that in your bearing we have 4 cardinal points, right? We have the north, the south, the east, and what? And the west. I will know before and now that between the north and the east is 90 degrees, and we assume this is the north, right? And this is what? The east. So between north and east is 90, right? So if you remove 45 from 90, what will remain? to still remain what? Another angle of what? 45 degrees. And we also know that between north and west is what? Is another 90 degrees. And between, let's assume this is the north and this is what? The west, right? So it is 90. So 60 minus 90, we're having the angle to be what? 30 degrees, right? So if you sum all this all together, 30 plus 45 is going to give me 75 degrees. So the angle between T1 and T2 is what? 75 degrees. Now similarly, let's assume this force coming down is the south, right? I will know between east and south is what? Is 90. So the angle between here and here also is what? Is 90. So 45 plus 90, so the meaning that the angle between these 2 points here is giving us 45 plus 90. And that will be what? 135 degrees. Now similarly, we know between west and south is also what? Is also 90. So the angle between west and this south here is like saying 90, right? So if I sum the angle between these two forces here, we say that 90 plus 60, that will give me 150 degrees. So if I should redraw this again here, right, just to make you understand better, if I should redraw this again here, I'll have something like this. I'll be having, let me come here, I'll be having something like this, and like this, and like this, right? So this is, I'll say this is my T2, this is the T1, and this is the weight acting downward, right? So the total angle between these two forces, between here and here, is giving us 135. The total angle between here and here is giving us what? 75 degrees. And the total angle between here and here is giving us what? 150 degrees, right? So as it is this way now, we are going to apply what is called Lami's theorem. We say Lami's theorem is telling us that if I have an angle, if I have three concurrent coplanar force, right? If I have three concurrent coplanar force, let's see, here is alpha, here is beta, and here is theta, right? And this is, each of them, we say maybe this is T1, T2, and what? T3. So Lami's theorem is telling me that I'm going to take the force over the sine of the angle between the two other forces, right? Now that was telling me T1 is equal to T1 over sine alpha, T2 over sine theta, because it is opposite it. They will have T3 over what? Sine beta. So the law simply says that when three concurrent coplanar forces acting at a point, right? When three what? Concurrent coplanar forces acting at a point are in equilibrium, then one of the forces is directly proportional to what? The sine of the angle between the two other forces. That is the Lami's theorem. So we are going to apply this rule on this. So if I'm applying this, so this will be like recall, right? You write this recall. So from here, if I want to do that, I will now move forward and say that T1 all over sine 135 equals to, this is T1 sine 135, T2 sine 150 equals to T2 all over what? sine 150, right? Then equals to W, which is the weight, over sine 75. W over what? Sine 75, right? So we know very well that W is given as 1000. So we see that T1 all over 135, that is sine 135, is equals to T2 over sine 150 is equals to 1000 over sine 75. I can't take these two, right? I cannot take these two because I have two unknowns, so I will take one at a time. So I can take, therefore, right, T1, let's move, T1 over sine 135 is equals to what? 1000 over sine 75, right? So if I multiply, this is coming up here, so I'm going to be having, I'll be having T1 is equals to 1000 sine 135, 1000 times sine 135 all over what? Sine 75, right? So calculator will have this. So 1000 sine 135 is going to be giving us 707.11, right? All over sine 75, and that will give me, divided by sine 75, so that will give me 732.05. So we have 732.05 Newton. So that is the tension T1, right? Now the next thing you do, the same thing, is you take T2 and this. So if I'm doing that, I'll be having something like this. So if I should take T2 here, so it will be for T2 over what? Sine 150 will give me 1000 over what? Sine 75. So the T2 will now give me 1000 sine 150 all over what? Sine 75, since I cross multiply. So applying your calculator here, so we say T2 will now give me, when you have sine 150, it's giving us 0.5 times 1000. That will give me 500, right? Divided by sine 75. So we're having 517.64 Newton. So that's our T2. So if you look at it, the T2 here, at this point here, T2 is giving us what? The force along the rope CD, and that is 517.64 Newton, while the T1, which is the force along member AB, 732.05. So this is equal to what? 732.05. So Newton. So if you found this video helpful, please don't forget to click on the subscribe button. Thanks for watching.